In this tutorial, we're going to show you how to import and unwrap a 3D model so you can set it up for toolpathing so you can cut it out on a machine. So this is what we're aiming to get to, but to do that, let's go and create a new file. So to do that, let's come up to File and Close. So let's go up to Create a New File. So let's click on Create a New File. Now in this case, we need a rotary job type. We're going to make this one 12 inches wide by 4 inches in diameter. My units are going to be in inches. My Z0 position will be off the cylinder axis, and that's because I don't know if my material is smooth all the way around. So I'm going to use the axis to zero off of because that'll give me a more accurate cut in this case, because I don't know if this is going to be a smooth, accurate surface all the way around. As for the XY dating position, it will be the bottom left. The orientation, in my case, it's along X. So what does that mean? Well, that means when I'm going to cut on my rotary axis, it will be along X. So it will wrap the Y moves into A moves. And so what will happen is the post processor, in my case, will be a Y to A post processor. And that will take all the Y moves in this case and wrap them into A moves. And that is what's happening here. So I will machine along the X axis, but the Y axis will be the axis will wrap around. Do double check this on your machine, because you may find that you actually have a long Y-axis setup, which will be a vertical rotary setup. In that case, the X-axis will be wrapped and you'll be cutting along Y. But in my case, it's along X, and if you're ever unsure about how it is on your machine, take a look at the machine itself, and if you're still not quite sure, contact your machine manufacturer. They'll be able to clear that up for you pretty quick. As for the modeling resolution, we're going to go for very high, and our material is set to Canadian maple for the appearance of the material, and we'll go and click OK. Now I'm just going to tile my views for the moment so I can show you the 2D and 3D view, because I want to show you this button just here. So if I click on this, this gives us a wireframe of our material when it's wrapped. You can see here that it is representing our rotary material. Now if you follow my mouse pointer over to the bottom left of the software here, you have the job dimensions. You have the width, which is 12 inches, which is the width all the way across. You have the height, which is actually the circumference, so this is all the way around. So that's why it's 12.5664, because it's the circumference of this job. And the depth is actually half of the diameter of our rotary job. And if you recall, we set it to 4 inches in diameter, so 2 is the depth. So the depth is 2 from here to here. Now that we've covered that, we need to actually look at importing some 3D data. So let's go ahead and do that. So if you follow my mouse pointer over to the top left here, just under File Operations, we're going to choose this option on the very far hand right side, which is the Import a Component or 3D Model. So let's click onto that. And you can see here I have this option here, which is the solid handle. Now it's important to note here that this is actually a Rhino demo file. So we can't unfortunately supply this to you to use, but regardless of that, the knowledge that you will learn in this tutorial will apply to models that you can import yourself. So don't worry if you don't have this exact model. Even if you bring in your own models, you'll be able to apply all the same techniques here that we're going to show you. So let's double left mouse click that to bring it in. And I'm going to maximize my 3D view. And I'm actually going to click on this icon here on the top right hand side, and this is the view control, so you can left mouse click and drag this around to whichever view you want. You can also simply click on a face and it will show you that face. In this case, I want it to face the front, so I'm quite happy with that. I'll just zoom out just a little bit so you can see everything we're working with here, and we'll now have a look at our imported model in depth. So what we have first is this blue bounding box around the model, and that actually represents the material. So the software has done its best to try and fit this model within that bounding box, or the material here. So this is where you can see it. So it's a nice visual to show you where the model currently sits within our material. The red line in the middle here is actually our central axis. So that represents the axis that we are working with, that we're rotating around. And we have some manipulation handles here to rotate the model around. Finally, on the left-hand side, you'll notice there's an arrow symbol here, and that represents the Z-axis. Now, this is where your cutter will come down to start cutting. So this represents the Z-axis, and your cutter will come down here and then engage the material to start cutting around in whichever axis you are wrapping. And when we actually imported the model, because it was a non-native format, it opened up our orientate or import 3D model form. Now, you can use all of these options to help better position the model within your material here. And the first option we actually have available is imported model type. So it can be a full 3D model or a flat model. So in this case, you need to tell the software if your model is a full 3D model or indeed a flat model. So you may want to use a flat model where you want to actually wrap it around another surface. But in this case, we're using a full 3D model, so we'll keep that one checked. As for the initial orientation, this is where you can actually orientate the model within the material itself using these options. So I'll just go through these in order so you can see what they look like. So if I click on right, that's not quite right for what we want to do here. So let's check out the front. The front's not so bad, but it's not quite as good as the top, I don't think. Bottom, just the opposite of the top. Left is just the opposite of the right. And back is the opposite of front. But for my case, I'm going to stick to the top because I think this will be the best position to work from at the moment. Again, you can also use the options underneath to rotate about the Z-axis. So in this case, you can go plus 90 degrees, plus 180 degrees, minus 90 degrees, and minus 180 degrees. But in this case, I'm going to stick with 0. Now what we're going to actually look at is manipulating the model within our bounding box here within our material to get the best fit. What we want to do is hide this axis. The reason why we want to hide this axis is because we want the model to be positioned in such a way that we don't get undercuts and we get both sides of the model represented, or all sides of the model represented accurately. So you can see I've got these rotation handles here. So I can left mouse click, and you'll notice when I hover over one of these handles, it will turn yellow to indicate that I'm currently activating that handle. And I can left mouse click and drag this into place. So you can see here now I'm dragging my handle in the y-axis or rotating in the y-axis, and I can let go. You can also enter a value, you notice there, when I click on it. I can simply enter a value if I happen to know one, and that will reflect it. And you'll also notice now if I right mouse click and drag this around. Now the axis looks pretty central on the front side. That's looking pretty good. However, on the back side of the handle, it's not quite centered. You can see there I need to move it over to the left a little bit, but also I need to bring it down a little bit. So because what will happen is when the software unwraps this, it will try to generate material underneath this area here where the axis is and where the next part of the model is. And we don't want that because we want to have the least amount of undercuts as possible because we want every bit of the model to be represented. So if you were to import something like a figurine, for example, this is where you may find some difficulty. You may need to establish another methodology because some models unfortunately will have undercuts no matter what you try. But in this case we can try and get rid of them, so we will do that. So let's have a look at some of other handles here. You can see I've got this blue handle in the middle, so let's click onto that. And it's now yellow, so I can now drag this round using left mouse click to position that. In fact, let's have a look at the other view here so we can do this in the best way possible. So we want to get that a bit more central. Just drag it around until it's looking nice and centered. There's a 0 value I've got there. And then I can also, you can see here I've got this green handle, and I can move that up and down. Now that's what we want. You can see there with my axis, it's now getting to a point where it's pretty central on the back end and in the front end. That is looking rather good. So this is what we want. We want the least amount of undercuts possible. That's looking pretty sharp. And what I can also do is actually manipulate the axis itself. So if I just click on the view control at the top here to bring it into right, if you hover your mouse over this central grey sphere, you can just drag the axis. So you can see I can now left mouse click and drag that into a position I want to place it. So I can just simply do that and then let go when I'm happy with it. And then I can do the same on the other side if I want to as well. But that is looking like I need to move it just a little bit. So I will just click on the left on the view control here. I'm just going to drag this. After hovering over it, just drag that middle icon. There we are, that looks pretty central to me. And then we can just check it from either side. Looking good so far. And that is a wonderful example of our model getting ready to be positioned for use in our design. Now here's another example of a model where we can try and get rid of any undercuts or try to align our model better so that we can alleviate as many undercuts as we can. It's important to remember that some models, it will just be impossible to do that, and you may end up having to remove it by other means, maybe after the part is finished or breaking up your part into several pieces. But we want to try our best to hide the rotational axis inside the component. So let's take a look at doing that now with this model. So we're going to use a combination of rotating the axes here and as well as hiding the middle axis in the middle of this table leg, just like we did with the handle earlier. So the first thing I'm going to do is actually click onto one of my rotation handles here. I'm going to rotate this back in just a little bit so it meets that red axis just up there. So I'm just going to lift that up until it kind of pops over the edge. That looks pretty good to me. So you've got a little bit of it coming through the top, but you can see the tail end meets, or the leg end meets the axis there. Now I'm currently in the top view. I'm just going to right mouse click and drag this around. You can also use the view control here to do so. I'm just going to drag that so it's pretty central. And you'll notice there's a black square just in the middle here. So when I hover my mouse over it, you'll notice my mouse changes to a crosshair. Now I'm on that black square. What I'm going to do is drag that, because it will drag the axis down into the table leg. So what the aim here is, I want to drag this down so that the red is no longer showing. So I want to put this as central as I can into this table leg, but without any of that red axis showing, so we don't get any undercuts. Because what we're trying to avoid here is, with this dip section here in the table leg, if we left the axis where it was, you would get a lot of undercuts and a strange looking model in the end. Now still, while holding right mouse click on the mouse, I can manipulate this view to have a look at where the axis is. And from the top here, I can see there's no red. So that's a good sign. That means the axis isn't coming through. So we've alleviated our chance of getting undercuts. And you can see they're relatively central on the front side here. And if you come around to the back side, you can see it's just kind of poking through just a tiny bit at the back there for the table leg. And crucially, underneath, it is not present either. So right now, that is looking absolutely ready to start toolpathing, so we can cut that out. Now, before we move back to looking at our handle model, there's one thing I should point out here, and that's because of where our rotational axis currently is and the way your CNC machine will work, that any details that are close to your rotational axis may have a hard time getting cut. So just keep that in mind when you're designing a part and placing your rotational axis within that part. Keep in mind that depending on how close that is to a detail of your part, you may have some difficulty cutting it. But with that in mind, let's move back over to our handle. Now that we're back onto our handle model, we need to look at scaling this model, because currently it's very large, and the reason why is because we imported it in units, but we can change that to millimeters, which would be around 170 millimeters, which is roughly 4 inches. So if I just go ahead and click on that, you'll notice that change reflect here. You'll also notice that it still says inches despite me choosing millimeters. Now the reason for that is because our job setup was in inches. But that looks about right now, and what we'll do is now have a look at the 3D view, because you'll notice in the 3D view, not only do I have the blue bounding box, I now have a red box inside here as well, red cylinder, and that represents our material. And you can currently see that our model is protruding from our material. So what we need to do is get the handle to fit inside of this red area here. And the way we can do that is we can actually change the model diameter. And you'll notice that the lock ratio option is checked. So that means if I change one of these values, the other value will change as well. But we also have this option here, which says to scale model to fit material. So let's click on that and see what happens. Now you'll notice I've got the bounding box around my handle, but crucially, the handle itself is now within our red cylinder. It's in the material, so it's scaled it to fit right inside of our material. And with that in place, I'm actually going to adjust the model length just a little bit, because you can see it's almost touching the ends of my material here, and I want just a little bit of room for error when it comes to finishing this off. So I'm just going to change that down to 10 inches. So I've got a lot more room here now, you can see on either end, for finishing and some room for error. I'm actually quite happy with that placement right now, so I'm going to go ahead and click OK so we can get that model imported in. And this is the result of all of the work that we put on earlier. So you can see now we have the imported model on our screen. If I right mouse click, I can just drag around my view here to see all the details that have been captured as a result of the orientation that we had put in earlier for the model import, and you can see there is a little tiny bit of excess material on the very end here, but that's nothing a little bit of finishing up and sanding won't take care of. One thing to point out though is if we go up to the top here in 3D view and we click on this icon here to show you the flat view, this is actually how the software interprets this job. What the software is doing is creating a 3-axis flat job, and it will wrap it around the y-axis. So currently, because I'm machining in the x-axis and my rotary is in the x-axis, so it's along x, that means all the y moves will be wrapped, in this case to the a-axis. So what the software will do is actually machine all of this flat, so this is how the model will be, and then the role of the post-processor is to wrap the y-axis moves into a-axis moves, which will give this result when you come to actually machine it on the CNC machine itself. Now you may be thinking, how are we going to machine this without it falling off the machine? Because currently we don't have any tabs on either end. Well, we can look at addressing that in just a moment, but to do that we need to have a look at our components tab. So let's hover over to the left hand side here and click on components, and we're going to have a look at our components tree on the left hand side here. So you can see here when we brought in our model, the software has our component listed here as a handle, so it's highlighted in red, and we've also got a zero plane here as well. Now the first thing we need to do is to change the combine mode of our handle. So I'm going to right mouse click it, combine mode, and set it to merge. Now the next thing I want to do to make our tab, I can show you a handy way of making this, is if we unwrap our model here, okay, I'm going to left mouse click onto our zero plane. You can see it's checked on the side here, so it's highlighted, and it's also highlighted in red on the actual 3D view. Follow my mouse pointer into the bottom here, and you'll notice I can now enter a base height. This symbol that is underneath the triangle indicates the base height of this zero plane. So I'm going to click on that, and I'm going to enter a value of 0.25, and I'll press enter. And then what will happen is when we go back to wrapping this, you'll see I now have some tabs. So it's increased the base height of that zero plane to help us naturally create a tab there. And there we go. That looks wonderful. So when it comes to actually machining this now, we can cut these away after we've machined away the rest of the material, and this will still be on the machine, so we can safely cut it at this end, cut it at that end, remove it, and then sand down what we need to get it looking like we want to. But with that in mind, we can now have a look at actually creating some toolpaths. So to do that, let's follow my mouse pointer over again to the top left, and we'll click on this icon to switch over to the toolpath command menu. And as usual, before we create any toolpaths, we need to make sure our material setup is looking good. So let's click into the set menu. And you can see we've got our diameter here from the start of the job, which is 4 inches. The XY datum again was in the bottom left. Z0 off the cylinder surface. And you'll notice the model position material, I've got a little bit of a gap outside the model. Now the reason for that is to give me room for error, because if I'm cutting this out and I'm not sure that the material has any ridges or any uneven parts, what I don't want is the model to meet the edges and then to reflect that with the cut having those uneven edges. So by having the model inside the material and leaving a little bit of a gap between the inside and the outside edge of the actual material itself, it can machine that edge away and then only leave our model as it's looking now, so we get a nice and clean finish. As for the wrap and Z gaps of the material, these are safe and sound for my machine. Do double check what they need to be for your machine, and if you need some further information on that, do not hesitate to contact your machine manufacturer. They'll be happy to help you on how to set these for your machine. But with that, I'm just going to click OK, and we're going to have a look at our first toolpath. So the first toolpath we're going to look at is a 3D toolpath. We're going to be using 3D toolpaths only because this is a 3D model. So the first one I need is the 3D roughing toolpath, which is just here on the toolpath operation menu. So the tool I need to use in this case, if I click on select, is a 1/4 inch bore nose. I'm going to click select. Now you notice there's an edit button next to the select button. Now this means I can edit the settings for that bore nose for just this job. So it won't permanently edit the tool database record, it will just edit it for this job. And I want to change the pass step to 0.25. I'm actually going to increase the step over to 40% and click OK. As for the machining limit boundary, I'm going to use the model boundary because I want it to machine the whole model. Not going to use a boundary offset, but I am going to leave a little bit of material behind for the finishing toolpath to clean up. So the machining allowance will leave just a little bit of skin behind for the finishing pass to clean up here. The roughing strategy I'll be using is a Z level strategy with the profile set to last and the order to do level by level. No raster angle in this case or ramp plunge moves, but I will just delete the one off this to call this one 3D roughing, and I can click on calculate. And you can see here the blue lines represent the toolpath. And what we will do is now preview that toolpath. So let's have a look at what it looks like. So preview selected toolpath. And as we've talked about throughout this, the software will treat this as a flat design and then wrap it. So you can see it is machined it flat and then wrapped it. So this is the result of that. And that is what I expect to see because it is leaving material behind for the finishing toolpath to clean up. Okay, so with our roughing toolpath ready to go, we can now have a look at our finishing toolpath. So let's go back up to the top here and go under toolpath operations, and we want this one here, which is 3D finishing toolpath. Now, I'm going to remove this tool here because I'm going to use the same 1/4 inch ball nose that I used for the first roughing toolpath, and I am going to edit it to change it to 10% for my step over this time, and click OK. Again, the model boundary is the machining limit boundary. We don't need a boundary offset at all on this one, but this time I'm going to use a raster strategy. And just to point out what happens with this, at its current angle of 0, what would happen is the tool would come down, engage the material and cut along X, because that's how we've got our rotary set up at the moment. Then it would rotate this by the step over that we've set, and then again machine along X. Whereas if you set this to 90 degrees, for example, what would happen instead is the tool would come down, cut all the way around here as this spins. So the tool would be here and this would spin to accommodate the cut, move over by the step over, and then this would spin and this would cut, etc, etc. But for now, because my setup's an X and this is the best use of it, I'm going to go for an angle of 0. In your case it may be different, so again, do double check how your rotary is set up. And we'll just call this one 3D finish and we'll click calculate. And then what you'll see in just a moment is, again, you'll see the blue toolpath marks here. You can see how it's going to cut away all that remaining material. So let's preview that selected toolpath, and again, you'll see it machines it flat and then wraps it around. So you can see all that material and all of that detail popping out now thanks to that finishing toolpath, and it's removing all that extra material that we had left behind with the roughing, which will mean that there's less stress put on your tool by doing it this way around. And there we are, that's the finished product, and we can easily cut off that tab, and then we can finish it off with some sanding when it comes to machining. Now at this stage you can actually save off your toolpaths for this file, but what you would need to do in your case is just make sure that when you select your post processor, it is a compatible post processor for your rotary setup. And we do have a video called Introduction to Rotary Machining, which covers how to save off G-code for rotary jobs. So I highly recommend you watch that, and that'll be linked in the description below for you as well, along with some other rotary videos that you might find useful. Now in this case, I would normally save this file off, but because, as I mentioned at the start of it, this is a Rhino demo file, and we do not have the license to give it out, I won't be saving it in this case, but the knowledge still remains. You can still save it in your case, and in order to do that, if you were going to save a file with your model in, you come up to File and Save As, so you can save your file that way with whichever model you bring into the software. But with that, that concludes this tutorial on how to import and unwrap a full 3D model for rotary machining. I hope you found it very helpful, and of course we look forward to seeing you in the next video.